So today we're going to talk about solving equations, and again we're going to be using inverse operations, but this time we are going to move on to two-step equations. Let's just review from yesterday. When we're trying to solve an equation, that means I need to find the value of the variable. So in an equation like this, a number 1, I need to find out what does m stand for. So to do that, I need m to be all by itself in this equation. So I'm getting rid of whatever numbers are on the same side of the equation as my variable. And to do that, I'm going to use the inverse operation. So the opposite of adding 12 would be subtracting 12. So as we move into two-step equations today, we're going to use the exact same process. So to undo addition, I'm going to use subtraction, and to undo subtraction, I'm going to use addition. And that's always going to be my first step. So remember, we talked about when we are simplifying expressions like we did last topic, we follow PEMDAS. We simplify parentheses, exponents, multiplication and division, and then addition, subtraction. But when we are undoing or doing inverse operations, we're actually going to go backwards through the order of operations. So first, I will be undoing addition, subtraction before I undo multiplication, division. And this is simply because we are undoing things. So it's kind of like a puzzle. We can put things together and then take it back apart. When we're undoing, we are in the taking back apart phase. So first, we're always going to undo the addition subtraction, and that's going to remove that constant term. My second step will always be to undo the multiplication or division, and that's going to remove the coefficient. So whatever number is being multiplied by x. So let's look at number 9 and see how this works. If my equation is 6x plus 8 equals 50, I want x all by itself, so I have to get rid of the plus 8, and I have to get rid of the times 6. 6 is my coefficient, so it's being multiplied by x. So to undo that multiplication, I'll use division. So that's going to be my second step. So for starters, I'm going to undo addition, subtraction. In this case, I'm adding 8 to my x term, so that's what I undo first. The opposite of adding 8 is subtracting 8, and whatever I do to one side of the equation, I have to do to the other, keeping in mind that I can only combine like terms. So plus 8 minus 8 cancels, that's 0. So all I'm left with on the left side of my equation is this 6x. I'm going to write my equal sign, and on the right side of the equation, I have 50 minus 8, which is 42. Yesterday, that's all we had to do was one step, and we had solved our equation. Today, I have an extra number to get rid of. So in my original equation, as I look at my variable, I have two numbers on the same side of the equation. So that's why I have two steps. Two steps to get rid of two numbers. So in my new equation, 6x equals 42, if I want x by itself, I need to undo this times 6. The opposite of multiplying by 6 is dividing by 6. Remember, we show division with the fraction bar. Whatever I do to one side, I have to do to the other. So I divide both sides by 6. These 6's cancel, so all I'm left with is x over here, and 42 divided by 6 equals 7. So that is my solution, x equals 7. Let's double check by substituting 7 back into our equation to make sure that it works out. So I'm going to do 6 times 7, because I'm putting 7 in for x, plus 8, and that should equal 50. So remember, now I need to follow the order of operations. I need to go forward through PEMDAS. So I'm going to multiply first. 6 times 7 is 42. And then I can add 8. 42 plus 8 is indeed 50. So this checks out because 50 equals 50. Let's try the same thing on number 10. 2x minus 5 equals 11. First, I'm going to undo the addition or subtraction. So I can see I'm subtracting 5 from my x term, so I'm going to undo that first. The opposite of minus 5 is plus 5. Whatever I do to one side, I have to do to the other. On the left side of my equation, the minus 5 plus 5 cancel, so all I have left is 2x. And on the right side, I have 11 plus 5, which is 16. In my new equation, 2x equals 16. I only have one thing to get rid of now, and that is this 2. So to undo multiplication, I'm going to use division. So I'm going to divide both sides by 2. 2 divided by 2 is 1, so those cancel. 1 times x is just x, and 16 divided by 2 equals 8. So I end up with the solution of x equals 8. Let's double check our work again just to make sure. So I'm going to substitute 8 back into this equation to make sure it works out. So I'm going to do 2 times 8 minus 5 equals 11. Following the order of operations, 2 times 8 is 16, and 16 minus 5 is 11. 11 equals 11, so that checks out. We're good to go. All right, on number 11. Same setup or same process, but a little different setup. This time, the left side of my equation only has a constant. It's the right side of my equation that has 2 terms. So I'm still going to use the same process. It doesn't change anything. I'm still looking to get my variable all alone. So I'm going to start by undoing the addition subtraction. So in this case, I'm adding 9 to my x term. So that's what I'm going to undo. The opposite of adding 9 is subtracting 9. Whatever I do to one side, I have to do to the other. 13 minus 9 is 4. Bring down my equal sign. Plus 9 minus 9 cancels to 0, so all I really have left is this minus 4x. So my new equation is 4 equals negative 4x. Now to get this x by itself, don't be fooled, I'm not going to add 4. I need to divide by 4, negative 4. Because I'm trying to undo this multiplication. Negative 4x means negative 4 times x. So the opposite of multiplying by negative 4 is to divide by negative 4. Whatever I do to one side, I have to do to the other. 4 divided by negative 4 equals negative 1. And that is my solution. I've gotten x by itself. Let's go ahead and check our work though, just to make sure that we've solved correctly. So I'm going to substitute negative 1 back into my equation for x. So I have negative 4 times negative 1 plus 9. Negative 4 times negative 1 is positive 4. And 4 plus 9 equals 13, so it checks out. All right, let's practice again on number 12. We're going to do the same process. 7 minus 3x equals 34. I need the x by itself, so I have 2 numbers to get rid of. I have to get rid of this minus 3 and this positive 7. I'm going to start by undoing addition subtraction. So I need to look at which number I am adding to x or subtracting from x. This negative 3, this is my coefficient of x, so this is being multiplied by x. So what I actually need to get rid of first is the 7. So if I have a positive 7 just sitting around, the way to get rid of a positive 7 is with a negative 7 or a minus 7. Oops, and that's not the color I wanted. It's supposed to be red. Whatever I do to one side, I have to do to the other. 7 minus 7 is 0, so all I have left on this side is the minus 3x. And on the right side, I have 34 minus 7, which is 27. Now my new equation, negative 3x equals 27, I just need to get rid of this -3, and it's being multiplied by x. So to undo that multiplication, I'm going to divide by -3. Whatever I do to one side, I have to do to the other. -3 divided by -3 cancels to 1. 1 times x is x. And 27 divided by -3 equals -9. So there's my solution. Let's check it to make sure we did it right. I'm going to substitute -9 back into my equation for x. So I have 7 minus 3 times -9 equals 34. Now a -3 times a -9 makes a positive 27. And 7 plus 27 is 34. 34 equals 34. So it checks out. Now on these last couple, as we look at these, you might be noticing already that we have some fractions we're dealing with. We don't need to panic. There's nothing too different about these fractions, especially on 13 and 14. So let's break it down and take it one step at a time. Remember, we said our first step is to always undo addition subtraction first, and then undo multiplication division second. So when I look at number 13, x divided by 2 minus 7 equals 9. I'm going to undo the addition or subtraction first. So I'm subtracting 7 from my x term. So that's what I need to get rid of first. So the opposite of minus 7 is plus 7. Whatever we do to one side, we have to do to the other. So minus 7 plus 7, those are additive inverse, so they cancel. They equal 0. So all I have left is x divided by 2. On the right side, 9 plus 7 is 16. And in my new equation, x divided by 2 equals 16. I only have one step to solve, and that's to get rid of this divided by 2. So x over 2 really means x divided by 2, and the opposite of dividing by 2 is to multiply by 2. Whatever I do to one side, I have to do to the other. So if I'm doing x times 2 divided by 2, then those cancel each other. So all I'm left with is x, and 16 times 2 is 32. Let's check our solution to make sure we did it correctly. So 32 goes in for x. 32 divided by 2 minus 7 equals 9. Well, 32 divided by 2 is 16, and 16 minus 7 equals 9, so it checks out. On number 14, same process, a little different look. Again, my x term is on the right side of the equation, but that doesn't change anything. I still have to undo addition and subtraction first. So the first number I'm going to get rid of so that x can be all alone is this plus 8. So to get rid of a plus 8, I'm going to do the opposite, which is minus 8. Whatever I do to one side, I have to do to the other. 11 minus 8 equals 3. Positive 8 minus 8 cancels to 0, so all I have left on the right side is x divided by -5. Now if I want x by itself, I need to undo divided by -5. The opposite of dividing by -5 is to multiply by -5. Whatever I do to one side, I have to do to the other. So over here, -5 times 3 equals -15. On the right side, I'm multiplying by -5 and I'm dividing by -5. So those cancel each other out, leaving me just with the x. So x equals -15. Let's check it to be sure. If I put -15 back in my equation for x, then I have 11 equals -15 divided by 5 plus 8. And a negative divided by a negative makes a positive. 15 divided by 5 is 3. 3 plus 8 is 11, so it checks out. 11